Imagine that you are building a robot that plays soccer.
Yeah.
And you've been to MIT computer science, you basically know how to do that, right? And so you would say the robot is an agent that solves a control problem.
Mm-hmm.
How to get the ball into the goal. And it needs to perceive the world, and the world is disturbing him in trying to do this, right? So he has to control many variables to make that happen and to project itself and the ball into the future and understand its position on the field relative to the ball and so on, and the position of its limbs or in the space around it and so on. So it needs to have an adequate model that abstracting reality in a useful way. And you could say that this robot does have agency over what it's doing in some sense. And the model is going to be a control model. And inside of that control model, you can possibly get to a point where this thing is sufficiently abstract to discover its own agency. Our current robots don't do that. They don't have a unified model of the universe. But there's not a reason why we shouldn't be getting there at some point in the not too distant future. And once that happens, you will notice that the robot tells a story about a robot playing soccer.
Mm-hmm.
So the robot will experience itself playing soccer in a simulation of the world that it uses to construct a model of the locations of its legs and limbs in space on the field with relationship to the ball. And it's not going to be at the level of the molecules. It will be an abstraction that is exactly at the level that is most suitable for past planning of the movements of the robot. Mm-hmm. Right? It's going to be a high-level abstraction, but a very useful one that is as predictive as we can make it. And in that side of that story, there is a model of the agency of that system. So this model can accurately predict that the contents of the model are going to be driving the behavior of the robot in the immediate future.
The agency comes from the programmer of the robot still, of what was programmed in.
You could probably do an end-to-end learning system. You maybe need to give it a few priors, so you nudge the architecture in the right direction that it converges more quickly. But ultimately, discovering the suitable hyperparameters of the architecture is also only a search process, right? And as the search process was evolution, that has informed our brain architecture so we can converge in a single lifetime on useful interaction with the world. And
I feel like there's always a human pulling the strings.
when you are looking at the current Boston Dynamics robots, it doesn't look as if there is somebody pulling the strings. It doesn't look like cheating anymore.
Okay, so let's go there because I got to talk to you about this. So obviously with the case of Boston Dynamics, as you may or may not know, it's always either hard-coded or remote controlled. There's no intelligence.
So, I don't know how the current generation of Boston Dynamics robots works, but what I've been told about the previous ones was that it's basically all cybernetic control, which means you still have feedback mechanisms and so on, but it's not deep learning for the most part as it's currently done. Mm-hmm. It's for the most part just identifying a control hierarchy that is congruent to the limbs that exist and the parameters that need to be optimized for the movement of these limbs. And then there is a convergence progress. So it's basically just regression that you would need to control this. But again, I don't know whether that's true. That's just what I've been told about how they work.
The only thing they do is pretty sophisticated control with no machine learning mm-hmm. in order to be to maintain balance. That's the only goal. Everything you see Boston Dynamics doing in terms of that to us humans is compelling. Dancing is even worse because dancing is hard coded in. It's choreographed by humans. So like there is no, of all that high level movement, there's no anything that you can call, certainly can't call AI.
The gap here is it doesn't necessarily have agency. What it has is cybernetic control. And the cybernetic control means you have a hierarchy of feedback loops that keep the behavior in certain boundaries so the robot doesn't fall over and it's able to perform the movements. And the choreography cannot really happen with motion capture because the robot would fall over because the physics of the robot, the weight distribution and so on, is different from the weight distribution in the human body. So if you were using the directly motion captured movements of a human body to project it into this robot, it wouldn't work. Mm-hmm. You can do this with a computer animation. It will look a little bit off, but who cares? But if you want to correct for the physics, you need to basically tell the robot where it should move its limbs. Mm-hmm. And then the control algorithm is going to approximate a solution that makes it possible within the physics of the robot. And you have to find the basic solution for making that happen. And there's probably going to be some regression necessary to get the control architecture to make these movements.
But those two layers are separate. So
yes.
The higher level instruction of how you should move and where you should move is a
so
higher
I
level.
expect that the control level of these robots at some level is dumb. This is just the physical control movement, the motor architecture. But it's a relatively smart motor architecture. It's just that there is no high-level deliberation about what decisions to make necessarily, right?
But see, it doesn't feel like free will or consciousness.
No, that was not where I was trying to get to. I think that in our own body, we have that too. So we have a certain thing that is basically just a cybernetic control architecture that is moving our limbs. And deep learning can help in discovering such an architecture if you don't have it in the first place. If you already know your hardware, you can maybe handcraft it. But if you don't know your hardware, you can search for such an architecture. And this work already existed in the 80s and 90s. People were starting to search for control architectures by motor babbling and so on, and just use reinforcement learning architectures to discover such a thing. And now imagine that you have the cybernetic control architecture already inside of you. And you extend this a little bit. So you are seeking out food, for instance, or rest, and so on. And you get to have a baby at some point. And now you add more and more control layers to this. And the system is reverse engineering its own control architecture and builds a high-level model to synchronize the pursuit of very different conflicting goals. And this is how I think you get to purposes. Purposes are models of your goals. The goals might be intrinsic as the result of the different set point violations that you have, hunger and thirst for very different things, and rest and pain avoidance and so on. And you put all these things together, and eventually you need to come up with a strategy to synchronize them all. And you don't need just to do this alone by yourself, because we are state-building organisms. We cannot function in isolation the way that Homo sapiens is set up. So our own behavior only makes sense when you zoom out very far into a society or even into ecosystemic intelligence on the planet and our place in it. So the individual behavior only makes sense in these larger contexts. And we have a number of priors built into us, so we are behaving as if we were acting on these high-level goals pretty much right from the start. And eventually, in the course of our life, we can reverse engineer the goals that we are acting on, what actually are our higher-level purposes. And the more we understand that, the more our behavior makes sense. But this is all, at this point, complex stories within stories that are driving our behavior.